Okay, so wonderful good afternoon, everybody. I welcome you back to HC Learning Academy. And of course, this happens to be our YouTube channel. If you are new to this channel, consider subscribing and also hitting the like button. And of course, if you want to register for personal lessons, you want to revise with us, you want to do revision classes with HC Learning Academy, especially for students from Lugush University that will be writing exams. Make sure that you register for personal lessons by inboxing this particular number, which happens to be a +260 777 46. Okay, and I'll be able to register you for personal lessons. That's the number that you contact. Today, I will be teaching you a very important topic under integration, which you're supposed to know by heart by keeping the concepts. It's the U-substitution. Now, U-substitution is simply the reverse of chain rule. Okay? Integration, by definition, is just the reverse of differentiation. Whatsoever you did in differentiation, now the reverse. So when we say U-substitution, we are simply talking about the reverse of chain rule. Now, how do you solve a question where you have been given let's say find the integral of 2x plus 1, then they give you to the power 5, then they say dx. Of course, the first thing you need to do, you need to equate whatever is in the brackets, you let it equal to u. So we can say you will let u is equal to 2x plus 1, right? Then we're going to have the u inside to the power 5, then we say dx. Then we can say du, then we find the differentiation of 2x plus 1, which is going to be, what is dy dx of 2x? It's going to be 2. Then of course don't forget dx. Then you can make dx the subject, so that you're going to have your dx is equal to du over 2. So we can replace, here you're going to have u to the power 5. Then while there is dx, I'm going to put du over 2. From there, we are going to factor out the 1 over 2 outside the integral. Then we're going to remain with u to the power 5 du. We have taken everything into the u out. Now we can finish up everything. Notice that 1 over 2 is going to be outside. Then we find the integral of u to the power 5. It is just 1 over 6, then u to the power 6. Okay? Plus c. Then this multiplied by that is going to be, of course, 1 over 12. Then what is u? The u was this particular part, which is going to be 2x plus 1 to the power 6 plus c. So this is how you find the integral of this particular equation. We go to the second, okay, which we can name them. Let me just put them in numbers. I think it will be better. Okay, so this is going to be the first question. The second question, they give you the integral of, let's say, x cosine, then they say x inside, then dx. How do you go about solving this particular equation? The concept, guys, remains the same. Whatever is in the brackets, let it equal u. So let u equal to x to the 2, right? Then of course, du is going to equal to 2x. Don't forget to put your dx. You can make dx the subject. Then this is going to equal to du over 2x. So I can get my integral, put my x there, then this is going to be cosine u. Then while there is dx, I'm going to have du over 2x. We can cancel the x and then cancel this x. So I'm going to have the integral of cosine u, then of course we have our du, like that. Okay, from there, what is cosine? Okay, so of course we have a 2, so we can factor it out. So this is going to be 1 over 2 outside because of this particular 2. We can factor it out. Then from there, remember, cosine, dy dx of cosine is negative sign, right? Negative sign, then dy dx of sine is equal to cosine. So whenever you're integrating cosine, you're just doing the opposite. Okay, so integral of cosine should give us a minus sign. Okay, so from there, we are going to have a minus outside, 1 over 2. Then, of course, wait a minute, it's going to be a positive sign because we are saying dy over dx of cosine is equal to minus sine. Okay, let me just put this. Then, of course, dy over dx of sine is equal to cosine. So, the one which was giving you a negative, whenever you are differentiating, should give you a positive this time around. And the one which was giving you a positive, whenever you are differentiating, should give you a negative this time around. It's the exchange. So because the cosine was giving us a negative sign, this time around to be a positive sign, so we're going to have a positive so it's going to be positive 1 over 2. Then of course this is going to be sine u plus some c. So we're going to have 1 over 2 sine, what is u? U was x to the 2 plus c. Basically, that is just how you solve that particular equation. We go to the third. So my main focus is simply to simplify things so that everything can become simple. You have the integral of 2x over x to the 2 x to the 2 plus 1 dx. So the first thing that you do, look at this HC. I think this is something that we even learned. You are supposed to equate, or you let your u equal to the denominator, right? Which is x to the 2 plus 1. Okay, so this is going to be 2x over u. Then of course you can say your du is going to equal to 2x, then dx, then over 2x all over by 2x. Then of course your dx is going to equal to your du over 2x. So what there is our dx here, we can replace with du over 2x. This and that can cancel. Then you're going to have 1 over u du. We have taken everything in the u out. Now, integral of 1 over u du is simply the natural log of the absolute value of u plus some constant c. So this is going to be ln. Then what was u? It was x to the 2 plus 1, then plus c. Basically, that is just how you solve this particular question. Okay, so let's check out this. You have, this is going to be question 4. You have the integral of 3x to the 2, open bracket, then you have x to the 3 plus 5 all over by to the power 5. Then they say this is your dx. So equate whatever is in the brackets, do the reverse of chain rule. So you're going to say you let u is equal to x to the 3 plus 5, du is equal to 3x to the 2 dx. And of course you make your dx the subject always, so that your dx can equal to your du over 3x to the 2. So now you are going to have 3x to the 2, u to the power 5, then of course your du over 3x to the 2. This and that can go. So when you cancel, you are going to have the integral of u to the 5 du, which is just going to be 1 over 6 u plus c, which is going to be 1 over 6. Then of course, what was your u? It was x to the 3 plus 5. Then this is going to be plus some constant c. Okay, that is how you solve this particular question. And I guess that's just like a repetition. Okay, let's solve question. This was question 4. Let's do question 5. Question 5 is just 5 over 5x plus 1 dx. And of course, you let your u is equal to 5x plus 1 du is equal to, you use the same concepts for anything that can come up. Okay, so this is going to be 5 dx. This is very simple. It's very simple. Even if the question is complicated, you have to know these basics that I'm giving out. You have to know the standard base where it is starting from. The concept remains the same. You make dx the subject so that your dx can equal to your du over 5. So you're going to have 5 over u, then of course du over 5, so that this and that can cancel. You're going to have integral of 1 over u du, which is just going to be the ln of 1, so the ln of 5x, the ln of u plus some constant c. Basically, that is just how you solve this particular question. How about if you have been asked to integrate? Let's say you are integrating x, then e to the x to the 2 dx. How do you go about solving this particular question? The first thing that I taught at C, you look at e. You need to look at the logarithmic part, then you look at its power, you equate it to u. So I'm going to say you let u is equal to x to the power 2. Then du is going to equal to 2x dx over 2x over 2x. And finally, your dx is going to equal to your du over 2x. So this is finally going to be something like your integral, then your x, your e to the u, then of course du over 2x. This x and that can cancel. Then you're going to have 1 over 2, the integral of e to the u du. E to the u is simply e to the u. Differentiation of e to the u is e to the u. Okay? Differentiation of integration of e to the u is e to the u. It maintains. So even this is going to be 1 over 2. Then of course it's going to be e to the u plus some constant c. So I'm going to have 1 over 2. Then of course e, what is u? It was x to the 2 plus c. Basically, that is just how you solve question 6. Okay, we go to question 7. Question 7, they are saying the integral of sine 4x, then of course dx. How do you go about this? It's the reverse of chain rule. You let u is equal to 4x, then du is equal to 4 dx over 4 over 4. You cancel. Your dx is equal to your du over 4. So you're going to find the integral of sine u, then of course du over 4. So you factor out the 4 so that you have the integral of sine u du. Now remember, dy dx of sine was positive cosine, so this time around it's going to be minus 1 over 4. Then of course this is going to be cosine. Then inside you replace your 4x plus some constant c. Okay. Question 8. Question 8 is simply the integral of x over x to the 2 plus 9 dx. You let your u, this one I've already taught, so it will be simple this time around even when you practice. So your du is going to equal to 2x dx over 2x over 2x, you cancel. Your dx is going to equal to du over 2x. Then of course this is going to be x over u. Then of course where you can put your du there over 2x, so that this x and that can cancel. Then you're going to have 1 over 2, the integral of 1 over u du. 1 over u, the integral of 1 over u du is simply 1 over 2, the natural log of u plus some c. So this is going to be 1 over 2 ln of what it was u. U was x to the 2 plus 9 plus some constant c. Let's see, this is very simple actually. You have to just understand the concepts. Okay, for a student learning from HC Learning Academy, mentored by the mentor Humble Kliman, this should be quite very simple. Now, let's do this particular question. We see question 8, this question 9. Okay. Question 9. You have an upper limit of 4, then you have a lower limit of 0, then of course you have the root of 16 minus x to the power 2 dx. Now, there are simple concepts that you are supposed to know about these particular equations, right, under integration. One concept I want to teach right now is the equation of a circle. The equation of a circle, for a full circle of this particular form, okay, let me do this. We call it circle geometry in engineering. So, if you have, let's say, a compass, let's say this is at some point 0, then you have a circle which is rotating at some point 360 degrees, right? Full circle. You're going to have the first quadrant, the second quadrant, third quadrant, the fourth quadrant. Each quadrant is a quarter of the circle. So this is going to be 1 over 4, 1 over 4, 1 over 4, 1 over 4. This is going to be your y greater than 0. The lower part is going to be your y less than 0. Okay? That's how it is. Okay, then this part is going to be your x less than 0. Of course, this part is going to be your x greater than 0, because that's the positive part. This is the negative part. An equation of a circle for a complete circle is simply y to the power 2 plus x to the power 2 is equal to the radius to the power 2. That is an equation of a full circle. Okay, in case maybe you didn't know. Now, this r is simply your radius, the radius of this particular circle. Okay, that is your radius. Then of course your area of a circle is simply your pi r to the power 2. So for questions which are going to have a root, okay, they have a root, or let me just say for questions which are going to have this particular form, a squared minus x power 2, use circle geometry. Use circle geometry. It becomes very simple. So the first thing that you are going to do, take whatever is inside here and equate it to y. So your equation is going to be some y is equal to the root of 16 minus x to the power 2. I want to show you something. So this is going to be this to the power 2, then this to the power 2. You're going to have y to the power 2 is equal to this, and that will cancel. You're going to have 16 minus x to the power 2. We can take it in this particular equation, the equation of a circle, which is this one. Then we're going to have y to the power 2 plus x to the power 2 is equal to 16. Now, remember that what we have is a radius here, and what we have is 16 here. So what number exactly do we have to power to the 2 and get 16? It is simply 4, meaning our radius for this particular equation is simply 4. That's very simple. It is simply 4, right? Now, you look at the upper limits. This, you have the lower limit. This is the upper limit, right? The lower limit, that is the upper limit. That is in the y. So, in the y, you're going to consider this one. In the x, you're going to consider that particular figure there, that particular limit there. Now, when you reach there, in the y, your upper limit is going to be a positive 4. Your lower limit is going to be negative 4. In the x, it's at the center, right? This is where your 0 is. So, our limit is from x, which is 0, to y, which is 4. So we are moving from 0, from this point to this point. It's at this point, right? So from 0 all the way to, let me just do this, to 4. So this is where we are going like this. You see? Because this is our limit. It's from 0 to 4. Okay? From 0 to 4. So, from this point where 0 is to this point where our 4 is. Because 4 is positive, it should be upward. That's what that implies. Right? Now, to be able to calculate this, just take a quarter of that circle and you'll be able to find this part. It becomes very easy. Okay? Okay? That is how you solve this particular question. So in fact, they just want you to solve a quarter of this particular question because already they've given you a square root of 16 minus x to the power 2. This entails you that this equation is simply y should be greater than or equal to 0. Because anything that is negative can't fit in here. Any value which is going to be a negative value, a very big negative value, we will not be able to fit. Okay, we can even prove this. Okay, let's try to prove. Let's say y is equal to square root of 16 minus x. Just want to prove this. Let's say this is our circle, right? Then we know that it's the upper limit, of course, this part. Now I want to figure out whether our graph is going to be here or our graph is going to be here. Okay? That's one thing that you must be able to know. Now, for this particular equation, your y should be greater than 0. So, whenever you get a value in the x-axis, let's say a negative 100, if you put negative 100 here, it's going to be a very big value, to which if you subtract with the 16 to give you a minus inside the square root, which will be undefined. And that is why this particular part can't be taken. Okay? So you always have to take a quarter of your circle, which is just 1/4. So you now get your area. Just get your area, then of course it's pi r to the power 2, then subject it to a quarter, so you say multiplied by 1/4. Then you're going to have your pi. What is, okay, 4 is, r is 4, yeah, okay, we figured out. Okay, then this is going to be 1/4, so this would be like 16 into 4 is 4, so area is going to give you 4 pi. So if you wanted to find for everything, the whole of this circle, let me just say half of this circle, let's say you wanted to find for this particular part, this whole area here, you just multiply this by 2. Okay, so you're going to have 4 pi. Henceforth, the integral of this particular thing is going to be 4 pi. Please make sure you take note. What I have just used is circle geometry. Circle geometry becomes very simple when you are integrating such values. Okay. Now, remember, I already have mentioned that you need to have this. This property must be there for you to use circle geometry. It becomes very simple. But if it's just like that, let's say they give you the integral of 4/0, then they say 16 minus x to the 2. This is very simple. Just go directly. You find the integral of this. Then whatever you are going to find, put this value in this integral. You put this value, you calculate the value. Then you say minus whatever you are going to find, put this value inside the same integral again. Okay? And that's how you solve. But whenever you have this property here, take note, use circle geometry. Okay? We go to another question where I'm going to give you a property which you shall use in your exam. Suppose you have a question where they are saying this is going to be, let me see, this is question what, 9. Then they give you the integral of cosine 7x. Then also they give you cosine 3x dx. How do you solve this particular question? How do you go about solving this particular question? So, whenever you have something like this, cosine angle at, let's say you've been given cosine 7x, cosine 3x, just weird numbers. You cannot use double angle formula. If you use double angle formula, it's going to be very difficult for you. So, how do you go about it? Use this particular concept. So, whenever you have been given this particular kind of an equation, or sorry, an integral, you're supposed to use this concept. So you have cosine mx, right? Cosine mx, and then you have cosine nx. This is going to equal to 1/2. Then you open the bracket. Then this is going to be cosine. It's the same concept you learned. So it's going to be cosine. You say m plus n inside, then x, right? Plus, then of course cosine, then m minus n outside, then of course x. So this is what you're going to use in order for you to be able to solve this particular question. With them we're doing double angle formula, we already taught this. Okay? Please make sure you know this property. Of course, I was able to explain from SC Learning Academy how you come up with such a formula under double angles, right? But I'm not saying use any other strength formula. Just go directly and grab this particular concept, okay? Now, you look at this particular integral. Your n, your m, is simply this guy here, which is your 7 This guy here is your n. So this is going to be, this is just the same as, we can factor out the 1/2. Then we're going to have the integral of cosine. What is m? Our m is 7. What is n? 7 plus 3. Then x plus cosine 7 minus 3 x dx. So this is just like 1/2. Then this is going to be cosine 10 x plus cosine 4x dx. Then we can just separate them so that we can have cosine 10x plus 1/2 integral of cosine 4x. Don't forget your dx everywhere. So you can start with this part. We can let our u equal to 10x, so that du becomes 10 dx over 10 over 10, and this becomes dx is equal to du over 10. Right, so you can just replace here. So it's going to be 1/2 integral of cosine. Inside you're going to put u, then of course you're going to put your du there over 10. Right, plus, so let's work out this part again. We let u is equal to 4x, then du is equal to 4 dx over 4 over 4. So dx is equal to du over 4. So even here we're going to have 1/2 cosine u, then of course du over 4. So from here we're going to have 1/20. Sorry, 1/20. Then what is cosine? What is the integral of cosine? Remember, dy dx of cosine was positive sign, so this will be negative sign, so it will be minus sine. What was u? The u was the 10x for this part. Then of course this is going to be minus because we are doing integral of this, so it's going to be minus 1/8 sine. This was 4x plus some constant c, and that's how you evaluate that. Okay, so this is very simple. Basically, this is quite very simple actually. All you have to know is this double angle property. The same also applies with cosine. Make sure you go back to double angles. When I was teaching trigonometry, I was able to give you the right double angles that you're supposed to put in whenever you are solving such very special equations. Okay, that's very, very important for you to solve. All right, we can try to do another. I think these are very, very important basic formulas I'm going to give you. The first one is going to be the integral of cosine squared. If you know this one, you can solve any, okay, which is going to have a power. If you know this one, you can solve any question of a cosine or a sine which is going to have a power. For example, like cosine 3 of x dx, or cosine, so it's supposed to be cosine squared of x. You can solve cosine 5th of x dx if you just know this. So remember that under double angles, I was able to show you, remember that your cosine squared of x was just equal to 1/2 open bracket 1 plus cosine 2x, and this implies that its relative sign is just going to be the opposite. So whenever you have something like this, replace with 1/2 1 plus cosine 2x, factor out 1/2 so that you can have 1 plus cosine 2x. Then of course you know what to do, just make sure that you separate them so that you can have the integral of 1 dx plus 1 over 2 integral of cosine 2x dx. And of course, you're going to have 1 over 2. What is the integral of 1? It is x. This part you use your U-substitution, of which we already know. This is going to be minus 1 over 2. And of course, this part is a sign, because that's the one which is given as the minus. Then everything, then the integral, which is 1 over 2. Okay? So the final answer is going to be x over 2 minus 1 over 4 sine 2x plus c. Basically, that is just how you solve this particular question. Lastly, let me see, this was question 10, this is 11. Let's do the last one, which is going to be 12. So this is going to be like sine 2x dx. So this is going to be, this is the integral. Of course, you replace, which is just going to be 1 over 2 1 cosine 2x so this is going to be 1 over 2 integral of 1 dx minus cosine 2x dx. From here, we're going to have 1 over 2. This, of course, is going to be some x. Remember that this is the sign, so you're going to have minus, then minus sine 2x, then all over by, so even this part is supposed to have 1 over 2. All over by 2. So this is going to be 1 over 2 x, then the minus, and this minus will multiply to be a plus, then 1 over 4, sorry, 1 over 4 sine 2x plus some c. Let's see, this is how you solve integration by U-substitution. You're simply substituting something by something so that you can make your work easy. These are very important basics or concepts that you're supposed to have in order for you to solve anything, right? So the moment you are able to understand this, you can solve questions that will look complex. Like, for example, they give you the integral of, let's say, cosine to the power 5 x dx. You already know that you can simplify this by simply breaking it down into cosine 3x multiplied by cosine 2x dx. The 2 part you already know. The 3 part is what you should be able to solve. It's very simple. The moment you just understand these concepts, everything becomes simple. Okay, if you found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to share and also register for personal lessons with a mentor, Hampier Kliman. Thank you so much.